All right, so hopefully you all watched the first video and you found everything to be pretty straightforward in a review of things that you have seen in the past. If you have any questions, obviously, we are going to have those Blackboard Collaborate sessions for our normal class time, which would be on Mondays and Wednesdays starting at 4 o'clock. So you can just tune in and ask any questions that you have at that time from those videos. So make sure that you're logging in and you're checking these videos and you're watching them and taking notes. So that way, if you have questions, you can ask those questions during our Blackboard Collaborate sessions, which I will send you the link for prior to those sessions beginning. So let's pick up again where we left off. So for the 2017 regular season, Major League Baseball leaders for home runs were Giancarlo Stanton of the Marlins, now with the Yankees, and Aaron Judge of the Yankees. These two players had a total of 111 home runs. Judge had 7 fewer home runs than Stanton. So Judge had, meaning his home run total was equal to 7 fewer than Stanton. So you have this Stanton minus 7. So his total was equal to 7 fewer than however many Stanton hit. Okay. And it also says that the two players had a total of 111 home runs. So if you take Judge's total and add it to Stanton's total, it would equal 111 home runs. Well, what we can do now is we can use substitution to take this amount right here, this 7 s minus 7, which we know that is the same thing as equal to j, and we can place that into this equation right here. And what that will do for us is it will give us a single equation with just one unknown. So we will have s minus 7, again, that's where the j came in from, plus, so the plus just comes along for the ride, this s comes along for the ride, is equal to 111. And now that we have like terms, we have 2s because we have s here and s here. So when we add those together, we'll get 2s minus 7 is equal to 111. And now we have a pretty garden variety equation that we can solve for in terms of s by adding 7 to both sides. And that's going to give us 2s is equal to 118. And then we can divide both sides by 2. Divide both sides by 2. We will get that Stanton hit 59 home runs. And if Stanton hit 59 home runs, we will know exactly how many Judge hit because Judge hit 7 fewer. So Judge will hit 52 home runs. And again, you can check your answer by adding these two values together because it says they hit a total of 111 home runs between the two of them. If you add 59 and 52 together, you get 111. Okay. So this is a pretty interesting one here. Deals with a very unique strategy. So it says a woman has $34,000 to invest. She invests some of the money into 4% account and the balance into a 2% account. So she's taking some amount of money, which we have no idea how much she's investing, into a 4% account. And then whatever's left over, she's going to put into this other account that's going to pay her 2%. And then we also know that the annual interest is $880. So that's how much she made for the year. Okay. So there's some background information that you need to know. That is the simple interest formula. So I is equal to PRT. So that's the simple interest formula. Principal meaning the amount of money that you're investing. R is your interest rate, and T is your time in years. The good news for us is that this is going to be 1 because it is 1 year, her annual interest rate. So T is 1, so there's really no need for the T for this formula. Okay. So what we're going to do is we are going to set X, some amount of money. So X is the amount of money that we are going to invest, or this woman is going to invest invest, invest, can't spell it today, this morning. So the amount of money that she invests into the 2% account. All right, so the amount of money that she's putting into the 2% account, which means the rest of the money is going into the 4% account. So we've got to figure out a way to figure out how much money is going investing into the 4% account. Remember, we can only use one variable here. So we have X amount of dollars going into the 2% account. And it doesn't matter which one you set this to be. You can say X is the amount of money going into 4% if you wanted to. It just doesn't really change the answers at all. Okay. So again, X amount of dollars is going into a 2% account. The rest of this amount of money is going into the 4% account. So the way that we set that up is we say that you have $34,000 to invest minus the X amount of dollars that you're investing into the 2% account. So this is exactly how much money is going into the 4% account, okay? And now we're going to use the simple interest formula, but we're going to have to add up two different accounts because remember, you have this total amount of interest, the amount of interest that she's getting here and the amount of interest that she's getting here, okay? So we have $880 is equal to the 2% that she's getting. Remember, you've got to convert this to a decimal times X. So that's our rate times the principal for the first account. So this is our first account. Plus the 4% interest that she's getting on the amount of money that's in the other account, which again we set as 34,000 minus X. This is the amount of interest that she's getting for the second account. So you take the amount of interest for the first account, the amount of interest for the second account, you add them together, and you get the total amount of interest for the year. All right, so we are going to distribute the 0.04 into our set of parentheses so we can start to solve this equation. So let's go ahead and do that now. So we've got 880 is equal to 0.02x plus 1360 minus 0.04x. Again, we got this by distributing our 0.04 into the set of parentheses. So the next thing I'm going to do is I'm going to combine like terms, and I will also subtract 1360 to both sides, so that way I can start to get x by itself. So that's going to give us negative 0.02x on the right-hand side, and that is going to give us negative 480 on the left-hand side. So let's say we have negative 480 on the left-hand side, 880 minus 1360. And then we just divide both sides by negative 0.02, negative 0.02, and we will figure out exactly how much money is going into the 2% account. So we take 480 divided by 0.02, and that is going to give us $24,000 that she is putting into the 2% account. And that means that that's going to be $10,000. $10,000 is going into the 4% account because 24,000 is going into the 2% account. Okay, so it's pretty slick how we were able to do this, even though it seems like there's too many unknowns that's going on here. The fact that we had some maximum amount of money that we had to invest was critical to being able to figure out how much money went into each account, especially since we knew the amount of total interest that she was able to earn for the year. Okay, so pretty cool stuff. All right, let's take a look at this next example. So how many pounds of candy worth $8 per pound should be mixed with 100 pounds of candy worth $4 per pound to get a mixture that can be sold for $7 a pound? Okay, so let's go ahead and do this. So we have much candy. So our unknown is X. We'll set that to be the amount of pounds of $8 per pound candy. So $8 candy. So there we go. So that's our unknown. And again, we're mixing these. So we're sort of adding the amount of pounds here to the amount of pounds of $4 candy, which they very nicely told us is 100 pounds. So this is going to be X number of pounds plus 100 pounds, okay, is going to be equal to some amount of pounds that's going to be worth $7 a pound. So this is $8 per pound plus this 100 pounds that's going to cost $4 per pound, which will give us some grand total of $7 per pound with the amount of total candy, which is going to be X plus 100, because you have X pounds plus 100 pounds of $4 candy is going to be some total amount of pounds that's going to be worth $7 a pound. And then we can start to simplify this pretty quickly. So we have 8X plus 400 is equal to 7X plus 700 after we use the distributive property. And to the right-hand side, subtract 7X to both sides, and also subtract 400 to both sides. So that way we can kind of kill two birds with one stone. We get X is equal to 300, which means 300 pounds of this $8 candy mixed with this 100 pounds of $4 candy, so that you can fairly sell it for $7 a pound. You know, and a lot of students in the past have asked, like, why would you do this? This is dumb. Why would you need to know something like this? Well, let's suppose you are a business owner and you have some product that you own. You have 100 pounds of this product that you simply cannot sell. You can't sell it because nobody wants it. It's, you know, maybe it's about to expire, something like that, right? Or people just don't generally like it very much. But somebody or people really like this $8 per pound product, okay? So how do you get rid of this $4 per pound product that nobody really wants? Well, maybe you can mix it with this $8 per pound product and sell it for a lower price, but it needs to be fair. You can't make it like a 50-50 mix and still sell it for $7 a pound. Nobody would buy it. They would say, you know what, I'm still just going to buy the $8 per pound candy. Maybe I'll buy less of it, but at least I feel like I'm going to get my money's worth. But this is sort of like how you do it. All right, this is the idea of what you could do. You can use some algebra to create this mix, create a price that is less expensive than the full $8 per pound candy, and you can try to get rid of this candy that nobody wants to buy. Okay. All right, so let's take a look at this guy. So how much water must be added to 20 liters of 50% antifreeze solution to reduce it to 40% antifreeze solution? Okay, so we are going to try to create this X amount of liters. So how much water? So this is going to be X, which is the amount of water. So amount of water, okay? And we are gonna mix it with 20 liters of 50% antifreeze solution. So this is 20 liters, that is at 50%. And we are going to add some amount of water X, which is 0% antifreeze solution. I know it's sort of weird, but there's 0% antifreeze in water, right? And we are going to try to create some mixture that is 40% antifreeze with the 20%, 20 liters of what we already had, plus the X liters of water that we are adding to it. So this is very similar to the problem that we just did with the candy, except we had to realize that, you know, water has hopefully 0% antifreeze, okay? So this is gonna give us 10. Obviously, this will go away completely, is equal to 0.4 times 20 is going to be 8 plus 0.4x. Subtract 8, you get 2 is equal to 0.4x. And then when you divide both sides by 0.4, divide both sides by 0.4, you get x is equal to 5 liters. So you are going to put 5 liters of water to get a 40% solution of antifreeze, right? So 1.4 is more of the same of what we did in 1.3, which are the word problems. Now, I don't want anybody to totally freak out because in 1.3 and 1.4, there are lots and lots of applications. That's what's going on here in the first chapter, in the first couple of sections in the first chapter. This class is not filled with all word problems, so don't freak out, don't hit the eject button. Things become more computational in nature after this section, so just bear with me for the first couple of sections here. And we won't do a ton from this section because, again, it's just further applications. It's just more word problems. All right, so Muhammad has a box of coins containing only dimes and half dollars. So dimes we know are worth 10 cents and half dollars are worth 50 cents. So I'll just kind of write that over here. There are a total of 26 coins and a total value of $8.60. So we know that if we add the dimes plus the half dollars, there are 26 total coins. And we also know that there's a total monetary value of $8.60. We can actually figure out how many of each denomination of coin they are going to have. All right, cool. So again, we know that dimes are worth 10 cents, and there are D number of dimes there, plus half dollars are worth 50 cents, times H number of half dollars is equal to $8.60. Okay. So what we can do here is we can sort of do what we did before, which is use substitution. So I can subtract D to both sides by getting H by itself, and you can subtract H to both sides, it doesn't really matter. And that's going to give you H is equal to the 26 coins that you have minus the number of dimes that you have in this box. Okay, so again, the number of half dollars is directly related to the fact that you have 26 total coins minus some number of dimes in this box. And what we do is we replace H with this 26 minus D. So this will be 0.10 times D plus 0.5 times 26 minus D is equal to $8.60. We can then distribute the 0.5 into the set of parentheses to get rid of the parentheses. So we've got 0.1 D, I don't need the 0, is plus 13 minus 0.5 D is equal to 860. And then we're just going to start to combine like terms. So 0.1 D minus 0.5 D is going to be negative 0.4 D plus 13 is equal to 860 minus 13 to both sides. You have 860 minus 13 will give you negative 440, and you still have negative 0.4d here on the left-hand side, divide by negative 0.4, and that will give you a positive value because a negative over a negative is positive. And when you divide by 0.4, you get 11. Okay, so you have 11 dimes in this box, which is pretty helpful because we will know now exactly how many half dollars we have, which will be 15 half dollars because there's a total of 26 coins. So if there's 11 dimes, that means that there's going to be 15 half dollars. All right, so this is pretty important stuff. These are standard style of questions in algebra. You know, 2 trains leave a station, that type of deal. So 2 cars leave the same town at the same time. One travels north at 60 miles per hour, and the other one is going south. So the key here is that they're going in opposite directions, and the speeds are not the same. That's not that critical, but the fact that they're going in opposite directions is 100% important here. And we need to figure out how many hours they will be 420 miles apart. So essentially, because they're going in opposite directions, for every hour that they travel, they are going 105 miles per hour apart from one another because they're going in opposite directions. Think about it. If this car is going north at 60 miles per hour, after 1 hour, it will be 60 miles north of where it started. So after 1 hour, it's 60 miles north of where it started. Well, this car, after 1 hour, is going to be 45 miles south of where it started, which means these 2 points are 105 miles apart from each other. So again, when they are going in opposite directions, all you have to do is add the speeds together to figure out what their miles per hour are. And we'd have the distance formula, distance equals rate times time. So our distance is 420, their rate is 105 miles per hour apart from one another. We can use this to figure out what the time is. So it is going to be 4 hours before these cars are 420 miles apart from one another. All right. Before I move on to the next example here, if they were going in the same direction, what we would do again, so if one car is going 60 miles per hour and the other car is going 45 miles per hour and they're going the same place. So we leave at the same time. You know, you drive fast and I drive a little bit more conservatively. I want to make sure that I don't get any tickets. So I want to take plenty of breaks. So I want to just average 45 miles per hour to get there. But we still need to go 420 miles. So we both need to travel, or we want to be 420 miles apart from each other. All right. So that's the idea. Again, we're not traveling 420 miles. We're traveling 420 miles apart from each other. So this car is traveling at 60. My car is only going 45 miles per hour. So for every hour that goes by, there's only 15 miles between us. So if you're going in the same direction, you subtract the speeds versus adding the speeds for this problem, okay? So again, 420 is equal to 15 times t, and we can figure out how many hours it's going to take for our cars to be 420 miles apart from each other. So a heck of a lot longer. So when I divide by 15, it's going to take us 28 hours, so more than a day, for us to be 420 miles apart from each other. Okay, so that's pretty important for you guys to see when you're going in the opposite directions, add the speeds, same directions, subtract. This one is pretty straightforward. I probably won't do this one in its entirety. You just have to remember from geometry class that you add the sum of interior angles and it's 180 degrees. So it's 180 is equal to x plus 61 plus 2x plus 7 because this is one angle, this is another angle, this is a third angle. You add up all the angles and it's equal to 180 degrees. Do a little bit of algebra, we'll be able to get the answer pretty fast for that one, okay? These are pretty cool, these consecutive integer problems or consecutive even or odd integers. One of the most common errors is when students do this one. Whether it's even or odd, you're always going to start with x and then add 2 to get the next value. Because if you are at, let's say, an odd integer, let's pick 5. To get to the next odd integer, you need to add 2. I know that you think odd numbers are 1, 3, 5, so this should be a 1, 3, 5, but it doesn't work that way. It doesn't work that way when you're going to consecutive odd or consecutive even integers. So again, if you're at 14 and you need to get to the next even integer, which is 16, you add 2 to it, okay? So add 2, add 2. If it's just consecutive integers, then you add 1, then add 2 to get to the next one. If you wanted a fourth one, you would add 3, and so on and so forth. All right, but this is the pattern that is developed when you are doing these types of problems. So find 3 consecutive integers which such that the sum of the first and the third is 49 less than 3 times the second. Okay, so 3 consecutive integers. So the first one is x. The second one is x plus 1, and the third one is x plus 2. That's the structure of the consecutive integers every single time. So again, we're finding 3 consecutive integers such that the sum of the first and the third is 49 less than 3 times the second. Okay, so the sum of this one and that one, so x plus 2, so the sum of the first and the third is 49 less than, so 49 less than, remember we're going to subtract 49, then 3 times the second. Okay, so 3 times the second, which is x plus 1. So this is how we set that one up. All right, it's pretty tricky, but we just sort of read it a couple of times, and as we read it, we put the things where they belong, the elements of this equation where they belong, and now we're more or less on easy street. So this will be 2x plus 2 is equal to 3x plus 3 minus 49, and we can start to move our equation to, we can simplify here, so this will be 2x plus 2 is equal to 3x minus 46. When you add 3 to negative 49, of course, you get 46. And we can subtract 2x, also add 46, add 46. And that's going to give us 48 is equal to x. So we have found the first integer. We found this one is 48, which means this one's 49. And the next one is, 50. All right. So 48, 49, and 50, because those are the 3 consecutive integers that satisfy the situation. All right, so let's talk about linear inequalities real quick. And again, I won't hammer you guys with a super long video for this one. We'll probably finish this section and then we will be done with this video. We're not done with chapter 1 yet, but we'll be done with this video. Chapter 1's pretty long. I think there's like 7 or 8 sections, so just bear with me. Okay. So inequalities, we know that these symbols exist. This is the less than, this is the greater than, less than or equal to, and greater than or equal to. So one of those things that you probably remember from back in the day was like the whole like alligator's mouth. You know, this one was always chomping on the bigger number. So you know, whatever you use to help you remember what these symbols do and which direction they go in and what they mean is entirely up to you. Okay. We solve inequalities by finding all real number solutions. For example, the solution set of x is less than or equal to 2 includes all real numbers that are less than or equal to 2. not just the integers that are less than or equal to 2. So all numbers. So not just, 0, 1, -6. It's negative 2.73 because 2.73 because that is a value that is less than or equal to 2. So one of the things that separates solving inequalities versus solving equations is that you have infinitely many solutions for every single one of these inequalities. There are infinitely many answers here that are going to satisfy this inequality. You can come up with so many of them that are less than or equal to 2. 2 is a solution. 0 is a solution. -7 is a solution. -7.3 is a solution. You can keep going until you're blue in the face. So there are infinitely many solutions, which means we're going to have to come up with a clever way to write these answers. We can't just keep writing the numbers down. That wouldn't make us very happy to do. All right. So what we do is we graph these solutions, or we use something that's called an interval notation, which we'll talk about in a minute. Okay. Sorry. What's going on here? There we go. All right. So what we do again is we start with this like little number line. Again, bear with me. I'm using a graphic pen, so it's a little bit difficult to do this. Kind of just throw like a 0 right here in the center. It doesn't have to be, but it's easy enough. This is pretty close to 0. We have 1, 2, and 3 over here. We have -1, -2, and -3. So I'll put 1, 2, 3, -1, -2, and -3. And it says we are going to place a square bracket at 2. And the reason why we're using a square bracket is because it's less than or equal to. So I'm going to put a square bracket here at 2, and then I'm going to draw an arrow to the left to represent the fact that all numbers less than 2 are also part of the graph. So I kind of do this just to shade what's going on here, to say that, hey, all of these numbers that are less than or equal to 2 are part of the solution. And then this is the graph that is associated with this. We can also use something that's called interval notation. So interval notation is some minimum value, comma, some maximum value. It's always in this order, all right? And you can see here that there's not really a minimum value. It kind of goes all the way to -infinity. So we are going to put -infinity, comma, some maximum value of 2. And we are going to use the same square bracket here, that we used because it was less than or equal to. If this were a strictly less than, we would use a parenthesis because it's not actually at 2, it's approaching 2, but doesn't actually get there. And the same thing here with this -infinity. It never gets to -infinity. -infinity is an idea, it's not a number, right? So it never gets there, so we are going to use a parenthesis here at -infinity because it is approaching -infinity. It doesn't actually get there. Where over here, it actually gets to 2. That is the maximum value because it's less than or equal to 2. So we used a square bracket. All right, so parentheses indicates an endpoint is not included in the solution step. So you're going to use parentheses when you see, less than, when you see greater than. Those are the symbols that you use parentheses with, and you also use parentheses with -infinity and positive infinity as well. All right, so those are the symbols, and these are the ideas that you're going to use parentheses with. A square bracket indicates that an endpoint is included, like we just saw. So that was the greater than or equal to 2. So you'll use a square bracket when you see less than or equal to, or greater than or equal to. Those symbols are going to indicate that you're going to use a square bracket. Parentheses are always used with the infinity symbol, which is something that I kind of already mentioned right up here. And the set of all real numbers is written in the interval notation of -infinity to positive infinity. So this is everything. All right, it goes, the minimum value is -infinity, the maximum value is positive infinity, which means it's going to go on forever in both directions and nothing is excluded. So we are going to write each inequality in interval notation, and we will also graph it. So bam, there's our graph. All right, so this is easy enough to graph first. So again, it's greater than or equal to. So I'm going to use a square bracket right there at -3, and I'm going to head in this direction right there because these are all the values that are greater than or equal to -3. And once you see the picture here, you can kind of come up with the interval pretty quickly. The minimum value is -3, and it is heading all the way to positive infinity, and you always use a parenthesis with the infinity symbols. Okay. This next one says x, this is the best way to read this one, x is between 0 and 3.5. So between 0 and 3.5, and you can see the symbols that we're using here, they should be parentheses because it's not less than or equal to, it's not less than or equal to, it's just strictly less than, okay? So x has to be greater than 0, x has to be less than 3.5. So we're going to use a parenthesis here at 0 and a parenthesis here at 3.5, and it says x is between those values. So there is the interval and the graph. And the interval will actually look just like this. It will be from 0, comma, 3.5, parentheses, and there's your interval. So this one actually looks like a point, which is a little scary for some of you. Some of you have this knowledge of the XY plane, which is what we're going to talk about in chapter 2. This is the interval from 0 to 3.5. This has nothing to do with where you graph this on the coordinate plane. We're dealing with a single variable here. There's no y to be found. So this is the interval from 0 to 3.5. It is not the point 0, comma 3.5. All right, just be careful with that. And this talks about the types of intervals, so what to look for. So again, this is what we just saw. It's called an open interval. 0 to 3.5 is, again, what we just saw there. If the endpoints were included, it would be from 0 to 3.5, including 0 and 3.5. So again, you can kind of like peruse this at a slower pace. I'm not going to go over each and every one of these. I think it's pretty self-explanatory. Okay. All right. So linear inequality in one variable, very, very similar to linear equations in one variable, except there are 4 different symbols, which is why you have 4 of them here. You have the less than or equal to, greater than or equal to. But everything else is exactly the same. You solve them the same way. You use the additive property of equality, use the multiplicative property of equality, except you're dealing with inequalities. One thing that you need to keep in mind is when you multiply or divide by a negative number, when dealing with inequalities, you must switch the inequality symbol, and I'll go over that once we see an example of it. But that is something that a lot of students forget to do, so I'm going to put that out there now, and hopefully you can remember it as you are going through your examples. Okay. All right, so let's go ahead and solve this. So again, we have trying to get x by itself. So if this were an equation, what we would do is we would add 5 to both sides, and we would get x is equal to 6. But that's not what we have here. We have an inequality, so we're going to get x is greater than 6, which is pretty nice. We can come up with this interval pretty quickly. Since x is greater than 6, we know that we're going to use a parenthesis at 6 because 6 is the minimum value, and it is heading all the way to infinity. So I've come up with the interval, even though it said I didn't have to. And then I'm going to graph the solution. So x is greater than 6. So x is greater than 6 is a parenthesis here at 6, and it's going in that direction. That's done. All right, so it's a little bit more tedious to come up with the answers to these inequalities because you have to represent them in either a interval or a graph. You can't just stop here most of the time because we want you to understand what this actually means. Okay, so let's do this one now. So again, same thing. We're going to get x on just one side of the equation. So minus 4x to both sides. This is going to give you x plus 3 is greater than or equal to -1. Subtract 3 to both sides. Subtract 3 to both sides. You get x is greater than or equal to -4. So there is your inequality. It's a greater than or equal to. So we're going to use a bracket at -4, and we are going to head in this direction because these are all the values that are greater than or equal to -4. We also know that the interval will be from -4, since that's the minimum, and it is heading all the way to positive infinity. All right, so you can see that the addition property of inequalities is very similar to the addition property of equations. Our solution sets are very different because we have infinitely many solutions to inequalities versus just either one answer, everything was an answer, or nothing was an answer back when we had equations. Remember those conditional, identity, or contradiction equations. All right, so multiplication property of inequalities. So again, this is the same as what was happening with the multiplication property of equations, with one exception. If C is negative, if what you are multiplying or dividing by is negative, you need to switch the inequality symbol. So you see how over here you started with the less than symbol. When you multiplied by a negative value, you switched the inequality. And the reason for that is very simple, basic. All right, maybe we can go into this in greater detail if you really want to, but here's the idea. Everybody knows that 1 is definitely less than 10. Everybody knows that. My kid who's in elementary school is using these symbols, and she knows that 1 is less than 10. Okay? The second you go into the negatives, so make both of these values negative, everything that's on the negative side of the number line is backwards. This value is no longer less than this one. If you owed me $1, it would be a lot better than if you owed me 10. So this value is greater than -10. So how did we land there? It is because we have multiplied this by -1. We multiplied this by -1. And we now have a -1 down here and a -10 down there. And since we're on the opposite side of the number line, everything is backwards, which is why we need to switch that inequality symbol. All right, so that's the reason in a nutshell. All right, so let's take a look at this guy. So again, we're going to divide by 4, divide by 4. You could also multiply by 1/4, whatever, it doesn't matter. X is going to be less than or equal to -25. Notice, I did not switch the inequality symbol. I did not multiply or divide by a negative. Yes, I got a negative over here, but I did not move from the negative side of the number line to the positive side of the number line. I was on the negative side, I stayed on the negative side. So I do not need to switch the inequality symbol. All right, so this is X is less than or equal to -25, which is right about here, and it's less than or equal to, again, don't judge. It's not super easy to do this. And there we go. And our interval is going to be from -infinity as a maximum value of -25. And we use the same symbol that we used on the number line. Okay. This is exactly where we're going to switch, because we are now dividing by a negative. And since we're dividing by a negative, we're moving from one side of the number line to the other. That's going to give us X is now greater than +9. -81 divided by -9 is +9. So we have a parenthesis here at 9 because it's a greater than symbol and it's everything in this direction. And we're good to go there. And I'll just keep hammering home this idea of the interval notation. So hopefully you can get the hang of that as well. All right, solving a linear inequality in one variable. So basically the same exact rules as equations. So I won't go too in depth with these. So let's bang out one of these, and I think we'll stop today's or this video. I don't know when you're watching these. So here we go. I will distribute, give me 6x minus 6 plus 3x is greater than or equal to -x minus 3x minus 6. So I've distributed everything that I needed to. I'm going to now combine like terms. So 6x plus 3x is 9x minus 6 is greater than or equal to -x minus 3x is going to be -4x minus 6. We'll go ahead and add this. So add 4x, maybe I'll add 6 and add 6. and that's going to give us 13x is greater than or equal to 0. All right, so negative 6 plus 6 is 0, which means x is greater than or equal to 0. And now that we have that, we will know that we have a bracket here since it's greater than or equal to, and we're heading in this direction because we want all the values that are greater than or equal to 0. And last but not least, I will hammer this home with a interval notation as well. All right, so hopefully you found this video to be helpful. I will continue to post them even though the semester has not started, although you're probably watching it once it has started. So thanks for tuning in. If you have any questions, make sure that you ask them during the Blackboard Collaborative meetings that are supposed to happen during our normally scheduled class time, which is from 4 to 8. Since I'm posting these videos, we will not be meeting from 4 to 8. I will start the meetings at 4 and they will end whenever you stop having questions. So sometimes they'll be 30 minutes, sometimes they'll be an hour and a half, maybe 2, but they will not be the full 4 hours and 10 minutes because I'm already posting the videos ahead of time. I don't think that any of you want me to lecture you for 4 hours and 10 minutes. This way you guys can watch the videos at your leisure and then you can ask questions during our class time. It's sort of a flipped classroom model where the expectation is that you are watching these videos prior to our class meetings so you can ask questions during those meetings. Okay, so thanks for tuning in, and I'll be posting some more videos soon.